Hey everybody, welcome to the next Timescale Twitch stream. Let's get started. My name is Attila Toth. I'm a developer advocate here at Timescale. What this show will be about is, as the title suggests, we will talk about stocks, crypto data. We will try to show examples and try to help people how to get started with TimescaleDB and whether you are dealing with stocks data or crypto data. And part of the reason we decided to create a show like this is that we have seen many questions and conversations around stocks and crypto in our Slack channel, in our Slack community. And many people are trying to work with crypto data or stocks data. They are creating open, high, low, close volume diagrams. Also, they are trying to analyze crypto prices. And basically, with this show, we are trying to help these people and show you examples and show you how to use TimescaleDB for these two use cases. And so, in this first episode, let me share my screen. So, in this first episode, I'm gonna be the host, but in later episodes in the future, also another Timescale Developer Advocate, 𝗥𝗲𝗹𝗃𝘁 will be uh, hosting this series. In this first episode, I'm going to talk about crypto, and then in later episodes, we also going to touch upon stocks, how to work with these different types of data types, how to store them, how to ingest them, and just really how to uh, make sense of the data, how you can analyze it. So maybe we should get started. Oh, and by the way, if you're watching the recording, there are links in the description that you probably want to check out, links to relevant resources and useful other links. Also, if you're watching live, I'm watching the Twitch chat, also the YouTube chat. So if you have questions or comments, you can use the chat panels. And yeah, so let me get started. So in this first episode, I'm trying to focus on NFTs, specifically NFT transactions, because recently, I think it's not just me, but I've been obsessed with like the whole NFT world from a data perspective, because there's a lot of different data fields when it comes to NFTs, and there is a lot of interesting insights you can get from analyzing NFT data. But the thing is, it's not very straightforward. There are not many examples out there how to do this. And so, with this episode, I will try to give you a quick overview how to get started, how to create the schema for storing NFT transactions, and I will also show you how to use the Timescale NFT Starter Kit, which we just recently published. That you can just clone, and you can run the ingestion script yourself. And it will fetch data from the OpenSea API. So let's get started. So today's agenda: first, we are going to take a step back and ask this question: is NFT data time series data? And this is an important question, because if it's time series data, then then there will be, in our example, uh, as we decided to focus on transactions, there will be one specific table that we focus on, and all the other tables and supporting data fields will revolve around this one specific table. So we are going to see how, if first of all, if time series NFT data is time series data, and if so, then how is it time series data? Then I will actually do a live demo fetching NFT data from OpenSea API. I will also show you an example NFT schema design that we have created for the NFT Starter Kit. This is just going to be an example. There are many ways you could do this, but this I think is a good first step if you're looking to enter into the world of NFTs from a data-driven standpoint. And finally, we also going to ingest data from the OpenSea API using the ingestion script and the tables that we created in the third step. All right, so is NFT data time series data? So first of all, let's just cover what is considered time series data, or at least what is my understanding what is time series data. So typically, with time series data, you are tracking changes over time. You are trying to find, how one or multiple values change over time, and what this enables you to do is basically analyze trends over time. Like for example, with NFTs, in the past couple of months, the NFT market has seen a big increase, and analyzing this trend might be valuable for you if in case you want to see the volumes, what kind of volumes NFT markets have, which collections have the highest volumes, which NFTs get traded the most, things like that. And also, with time series data, you're typically collecting data in given time intervals. So this could be maybe you are collecting data in every minute or every hour, and you are basically not just care about what's the current state, like what was the most recent value. You also care about the historical changes. So with NFTs, for example, you want to know, what was yesterday's volume for a given collection, but then you also want to know what was the volume the day before that, or the a month in the past, and this way you can visualize time series data using time series charts, and you can see historical changes, you can see the trends over time. And again, with time series data, you typically record new data as new rows in the database, new entries, and you don't do any updates. So you do a lot of inserts. You just insert new records, new values, but you don't update those because you want to actually store value from history so you can analyze it over time. All right, so this is just context what I consider time series data. And then let's see if the kind of NFT OpenSea NFT data set that we will be working with, whether that's time series data or not, and what aspect of the data is time series. So is it maybe the accounts that we can consider time series account, meaning an account that can buy or sell NFTs on OpenSea? I will show you examples later on. Or is it the asset, the specific NFTs that can have a value data fields like the name of the NFT or the image URL of the NFT? Or is it the collections, which is you can have multiple assets in one collection? Or is it maybe the events, the time series aspect of the NFT data? And to really see what these, I guess we could call these data types. So what these data types include, let's have a look at actual examples. If I can switch over to VS Code. So I have 4 sample files here to see, what these data types actually include. So for example, this one, maybe I increase the font size real quick. So for example, this one, this is a JSON object. I fetched it from OpenSea using the OpenSea API. I will show you how to do this. But this is an example response or an example, data of an account. You have, the username, which in case it's null, but you have a profile image URL. You have an address, which is very important. It's unique in case of accounts, and basically it's one of the most simple data types when it comes to NFT data. But this is what it looks like. A slightly more complex JSON is the asset object. So here you can see some of the data fields of an asset object. There are many things we could highlight, but maybe just go through some of these. So the ID, which actually comes from OpenSea, and it's how OpenSea stores the NFT. We have token ID and all kinds of attributes of the NFT, like background color, image URL, description, name of the NFT, external link. And then here we have a nested object, which is the asset contract data field. It has a more detailed, lower level data fields about that specific NFT. Things like when was the asset contract created, the contract type, which is in this case non-fungible because we are talking about NFTs, which is non-fungible token. We have info about fees. We also have permalink, which is basically the OpenSea URL of one asset. We have here the owner and the information about the owner. In this case, this response doesn't have information about the owner, but we have information about the creator who created this specific NFT. We have the address of the owner, and we have other data fields. Now let's look at collections. So this is one example collection, and I think it's it's CryptoPunks. So it has a lot of attributes of the collection. We got creation date, when was the collection created, description. We also have Discord URL. We also have image URL, and we have some social usernames as well, and an important data field, which is the collection slug. The slug is unique, unlike the name of the collection. That's not unique. And then finally, let's look at the most interesting sample data, or at least the most interesting from a time series perspective, which is the event data, which has probably the most data fields, but it also has the price data fields, which in this case I think it's an offer event. That's why the total price is null. But if we look at let's see. So if we look at the bid amount, that's how you know that it was an offer, and that's why you have a bid amount but not total price. You can also query events that are that were actual sale transactions and not offers. And here you also have account information. In this case, the account used to make this offer. You have a payment token item here, which in this case is Ether. So Ether was used to make this offer. And then a time series aspect of this JSON is that you have the Ether to USD price captured here, which obviously changes over time. It's always changing over time. But also the other price value, the bid amount, that's also a time series data point, and it's one of those data fields that make it a really make it time series data, especially if you are trying to analyze prices over time, or you're trying to calculate the average prices of a given average price of a given collection in a given time period. So these are very important data fields if you're interested in analyzing the prices. And then we have some info about the transaction. Technical fields like the block hash, block number, timestamp. So we have a lot of interesting fields here. And what we are trying to do now, so these were just sample data fields, but let's try to actually and we didn't answer the question. So is NFT data time series data? And again, you can look at it in from multiple perspectives, but the perspective that we had is that we are focusing on the events, which are as you saw, it can be an offer made, or a sale transaction when someone actually bought an NFT. And we consider that time series data because we are interested in the changes that are happening over time. We want to see how the sale prices change over time, whether the average price of a given NFT or collection goes up or down. So we consider that time series data. And when it comes to the other elements, accounts, assets, and collections, obviously they are also important because an event has basically connect these other data types together. So for an event, you have a sender account, which let's say in case of a sale transaction, you have an account which sends the NFT, and then you have an account which receives the NFT because this account bought the NFT. Or you have collections, which is important store if you want to analyze not just individual NFTs, but collections like 𝗥𝗲𝗃𝗀𝗃𝗁 or 𝗥𝗲𝗃𝗀𝗃𝗀. And an account can be useful if you are trying to learn about specific NFT or OpenSea users, or let's say you are following an NFT trader or a person who often buys and sells NFTs, and you're trying to learn what's their strategy, what they're doing, what they are buying, what they are selling. And if you're storing this data point in your TimescaleDB or in other database, you can analyze that aspect of the data as well. All right, so with that said, what we're going to do now is we are going to fetch real NFT data from the OpenSea API. We are going to use this package that I published not so long ago, which basically requests, it uses the OpenSea API under the hood. It just simplifies the whole process of making a request, applying different query parameters like how many events you want to fetch, or what collections you want to fetch. And so if you want to try this library, you can just use you can just install it with pip install OpenSea API. And so let's do this right now. Also link in the description if you're watching the recording. So let me go over to VS Code. And so as I said, I already have it installed, but just to show you how this works. So you need to pip install OpenSea API. This will install the package. And then once you've done that, we're going to use a Jupyter notebook here to show you how you can fetch NFT data. So after you install the package, you need to import the OpenSea module. So let's click execute this row, and then let's fetch some NFT data. So first, maybe fetch events data, and to do that, we need to create an OpenSea events object and call the fetch function. And as optional parameters, we can define the JSON file that we want to download the data into. If you don't define this, it will just it will just put the response in your terminal. But now we will create a JSON file, and we also define a limit to only get one event back. So it's going to be a smaller JSON file that we can easily dissect. So let's try to run it and see if it works. And as you can see, it returned the JSON object. And let's look at the actual JSON file in the export folder. It's just one row, but let me format the file so we have an easier time to look at the data. All right, so as you can see, this is what the OpenSea API returns. It's a huge JSON file. Well, it's not huge, but it only contains one event. And as we have seen previously in the previous sample, it has the same data fields. We have ID, token ID. We have one interesting thing is that this response from, if you make a request to the events endpoint, which we did using these two lines, this response will actually contain not just the actual event data, but also data about the asset that was part of the event. So for example, this is where the data fields of the asset starts. And so these are all related to the asset. And then as you can see, there's also a nested object here for the asset contract. So there's a lot of stuff here. And you also have the collection object nested here. So basically, if you want to if you want to fetch events data, you don't need to worry about making a separate request to get asset information and making a separate request to get collection information, because everything is here in this one JSON file. The only limitation is that maybe not all the available fields are in here in the nested objects, but as you can see, you have in case of the collection object, you have the name of the collection, you have different URLs of the collection. So this should be enough to get you started analyzing NFTs, because you can use this to group by collections and analyze assets inside a collection. Then we also have owner of the NFT. We have, as you can see, we also have bid amount, which indicates that this was an offer. But in case we want to query actual sale transactions, because we are interested in sale transactions, what we can do is we can just define a new parameter here called event type. And if we say successful, so we are only interested in successful events. Successful indicates a successful sale. So if we run this, this will give us one event. Let's format it again. This will give us one event, which was a successful transaction. And if we go here, the bid amount is null because it wasn't an offer. There is no bid here, but instead we have total price, which is the price in Ether or in other cryptocurrencies used here. And you also can find what currency were used in this transaction. If I find the payment token JSON object somewhere here. So this is the total price, and I cannot find it now, but there is a field somewhere in this huge JSON which indicates what payment symbol were used for this transaction. But as you can see, we also have info about the collection. We have asset data fields. So this is a really good endpoint to fetch time series data, but still be able to fetch, other data like collections and assets and accounts that participated in the event. But let's try the other endpoints real quick. We also have an assets endpoint, which gives us a more detailed information about an asset. So if I run this and open the return JSON, we see that we have all the other fields that were part of the events response, and we have additional fields like creator, for example. So using this endpoint, we can learn who created the NFT, and we also have a traits object here, and other data fields that might be interesting for you. Then let's try the next endpoint, collection. So with this code snippet, we can fetch data about the defined collection. In this case, in this example, CryptoPunks, which is one of the most popular collections. You just need to provide the slug as a parameter. So if you run this, this will query the OpenSea API, and here's the response. Let's open the JSON. And so here we have a lot of additional data fields that might be interesting, like the account addresses of the editors of the collection. We have payment tokens of the collection. As you can see, it's not just Ether. We have a primary asset contracts, traits, a lot of traits, because there are different versions or different assets in the collection, types, other stats. So there's a lot of stuff here. If in the schema that I will show you later, simplifies this whole response. So we will only select a few very important data fields, like the name of the collection, the slug of the collection, which is, as I said, it's unique. So moving on, I think I have two other endpoints that I wanted to show. One is the contract endpoint, which could be interesting for you if you want to see data about a specific asset contract, and you only care about the actual contract. data fields. So here I just inserted here an example contract, an example address, contract address. So if you run this, this will create a JSON for us, and this has even more data fields. I think it's a CryptoKitties asset contract, and basically you have info about the collection and some other lower level data. And then finally, bundles, which are a little bit more complex to store. But let's see an example. So here in the as a parameter, I defined the same asset contract address. So now we will see bundles. We will see one bundle, because I also defined a limit parameter. We will see one bundle of the given asset. So if I open the response and format it, we can see who made the bundle. We can see what is the slug. We can see what assets are in this bundle, and as you can see, it's a bigger list. We have info about the asset contract and a lot of other things. All right, so moving on, this is how you can use the Python wrapper library if you want to get NFT data. What we're going to do next is show you an example NFT schema, which you can also find in the NFT Starter Kit in the Timescale GitHub page. You can go to the short link on the slide, and that short link will lead you to this repository, which is the Timescale NFT Starter Kit. It has a lot of interesting components: data ingestion script, a simple NFT data set, the schema that we will use in this stream, and it also has a local a Docker image that you can just build locally, and that will build out a local TimescaleDB with pre-built superset dashboards, so you can get started analyzing NFTs in literally like 4 minutes. But what we care about right now is the schema script. So we created this schema, which is which intends to store or create tables to store data that I just showed you in JSON files. And this schema is a simplified version of the JSON files, or maybe I should say that it's a simple schema to get you started and to be able to run meaningful and interesting analytical queries on the data set. And with this, you can expand on this. You can include other data fields that I just showed you in the JSON, because there are all kinds of data fields, and with this example, for example, you can easily analyze events. You can analyze prices. You can analyze it from a time series perspective, how they changed over time, and you will be able to get other useful supporting information about each event, regarding the asset that was part of the event, and the accounts that were part of the event, and the collection that was part of the event. And event meaning in this example sales. So this schema only focuses on actual successful sale transactions. And so, for example, here you won't find like a bid amount value, which you only have in the JSON if it was an offer. In the case of sales, you have total price as the price value. So we have this schema, and let me go through the different data fields or columns that we create in these tables, just to really get a sense of the data and the tables that you will create if you decide to run this SQL script. So first we have a collections table, which will store data for unique collections. We have an ID. Have an ID data field, which is going to be automatically generated by Postgres or TimescaleDB, and it will always give a new unique ID to when we insert a new record. It's basically the Postgres equivalent of auto increment in MySQL. If you're familiar with MySQL, but it will be always, it's a primary key, and it will be always unique. Then we have another field, slug, which is also unique. It's always unique. There are no two collections with the same slug. And then we have name, which is the name of the collection. We have URL, which is going to be the OpenSea URL of the collection. And then we decided to create a details JSON-B column, which basically stores everything else that we can find in one JSON response. But we decided not to create a separate columns for. So basically, this allows you to store everything that is part of the response. If you ever decide in the future that, hey, you are interested in I don't know, the image URL of the collection, you can still get it from this JSON-B column. Then we are going to create an accounts table, which will store information for accounts. Here we have an ID, which is the same as with collections. It's going to be generated by Postgres, and it's going to be a new ID every time we insert a new record. We have username. We have address. The address is never null, and it's unique. And as previously, we have a details JSON-B here as well for similar reasons to store every possible data field that the JSON response has. And we have a set. Here we don't have the generated ID. Here we get the ID from the response. So if I go back here, the assets JSON file, and I scroll up, here's the ID. So we just get it from this JSON, and that will be stored in the database. Then we have the name of the NFT. We have a collection ID, which is a foreign key that references the collections table. We have description, the description of the NFT. We have the contract date, which basically the creation date of the contract. And this field is a time zone timestamp field, so it is time zone aware. Then we have a URL, which is unique. We have image URL, owner ID, which is which references the accounts table, and we also have the details JSON-B column, which has all the other data fields one asset has in the JSON file that we got from OpenSea. Then here, with this line, create type auction, we create a new type called auction. It's an enum type, because there can be only, in our experience at least, on the OpenSea platform, there can be three auctions or auction types. It can be Dutch, English, or minimum price. One of those, if it was an auction. And and that's why we created this type. And then here is the main time series table called NFT sales. Here, similarly as with assets, we get the ID from the JSON file. Then we have the time column, which is a time zone over timestamp field. And then we have two foreign keys, one for asset ID and one for collection ID, which these columns reference the asset and collection tables. Then here we use below that the auction type that we just created before the table creation script. We have a contract address, we have quantity, which is numeric, interestingly, because there are, based on our experience, there are quite a few NFTs that were for some reason created in huge quantities, and that's why this data type needed to be numeric. Then we have payment symbol, which can be ether or some other symbol that is accepted on OpenSea. We also have total price, which is double precision. And then after that, we have 4 columns, which they all reference the account table, because in each event we have 4 accounts: seller, from, to, and winner, and and they all get this information from the account table. So if there's a new event, the new accounts will be inserted to the account table. The new asset, if it's new, then it will be inserted to the asset table, and then if the collection is new, then it will be inserted to the collection table. Then, as I said, the NFT sales table is a time series table, and so we convert it to a hyper table with the create hyper table function. And this way we can TimescaleDB will partition this table based on the time column, and it will be more efficient to query this database and run time series functions on this table. And then we have created 4 indexes here to make querying more efficient. We have one for assets, collections, the payment symbol, and the winner count. But this is also this is just what we decided to create. There are many, there are other indexes that you might want to create instead, depending on what kind of queries you are going to run, which columns you will often reference in where clauses and inner join clauses. So it depends on the queries that you will run. So with that said, let me copy this whole SQL script, go over to 𝗙𝗵𝗽, where I have a totally empty Timescale Cloud instance, without any tables, without anything. And we will create this we will create these tables from scratch, and then we will after creating them, we will ingest data using the OpenSea wrapper library that I just showed you. By the way, if you want to just quickly get a working TimescaleDB instance, this is probably the easiest way. You can just go to timescale.com and try Timescale Cloud for free. You don't even need a credit card, and you will have, or you can have, a working TimescaleDB instance up and running in a few minutes. All right, so if I paste the schema script here that I just explained earlier, let's run this and see if it works. So if I run this, there are a lot of things going on. TimescaleDB created a hyper table, and all the other tables have been created that we can see on the left. If I hit refresh, Yes, so we have now an accounts table, assets table, collections table, and NFT sales hyper table. So the tables are ready. And now the next thing that we're going to do is actually ingest ingest data from the OpenSea API into this new Timescale Cloud instance and tables that I just created. If you want to grab the source code, you can go to the chart link, which again leads you to the NFT Starter Kit GitHub repository, which has which is everything, all the files that you need, the schema SQL file that I just went through, and also it has an OpenSea ingest file, which will actually do the ingestion. But you don't need to modify this. There are instructions in the GitHub README, so you can read it. But basically, you need to modify the config file. You need to put here the connection details of your database, and then you need to define the OpenSea's start date and end date, which basically indicate from what time period you want to ingest data from. So, for example, if you use these two values, it will ingest data. It will ingest NFT sales that happen between the 1st of October and the 6th of October. All right, so it's very simple, and then you need to run the OpenSea ingest.py file. So let's do that. So I already cloned this repository. Oops. Let me open a new terminal. So I already have the NFT starter kit repository cloned, and basically you just need to, after you set the after you modify this configuration file with the proper database connection details, you can just go ahead and run the Python script, Python OpenSea ingest, and then if you run it, it should start ingesting data. My defined time period is the 1st of November and the 10th of November, so between those two dates. And right now it's fetching data from OpenSea. Then it loads data into a temporary table, and then it actually ingests the data with TimescaleDB, and the terminal always shows you the last time of the or the last inserted row's timestamp. So currently we have I keep it running for a few seconds, so we have a couple of hundred, maybe a couple of thousand records. But basically we can already, I can keep this running. We can go to 𝗙𝗵𝗽 and try some queries, because hopefully there are some data here actually ingested already. So let's see how many assets we have at this point. So we have 904 assets. Let's see if I can make this bigger. Yes. We have 904 assets. Now, if I run this query again, now we have more than 1,000. So as you can see, the ingestion script that we are running here actually works. Then let's see how many collections we have. So we have 439 collections. How many accounts? 1,624 accounts. And let's see the most interesting table, the NFT sales table. So the NFT sales table has 2,397 rows, which again, it only contains sale transactions. And as you can see, currently we have data starting the 10th of November, and the time is 2:49 p.m. roughly, and the last date is 10th of November, 4 p.m. 4:14 p.m. So currently uh, it's it's less than 2 hours of data. But if I run this query again, the minimum date should get updated, and it got updated. So we have data coming in continuously. Now let's try some other queries. So for example, if you want to see what payment symbols are used, as I mentioned, there are multiple symbols, payment, multiple currencies that you could use. So if I run this query, this will use the NFT sales table and show the different payment symbols used in transactions. So as you can see, for a lot of events, we actually don't. The JSON file didn't contain any payment symbols, but it did. Most of the records had Ether as the defined payment symbol, and you can see the other payment symbols in the return table. Then let's see the assets that have been the most often sold in this period, which again currently it's about 3 hours, almost 3 hours of NFT transactions. So if we run this query, we get a list of NFTs with URLs. So for example, we can see that this NFT was most often sold in the defined time period. We can actually look up this NFT on OpenSea. So as I just click the OpenSea URL, and this looks to be a popular NFT. As you can see, there are transactions that literally happened in less than a minute ago. And then these are the other popular NFT that have been traded in the time period. And finally, just to show another example query, we can see we can look up one specific collection. So, for example, look up 𝗥𝗲𝗃 as that collection is one of the most popular collections, and see some aggregated data from our time period. So this query will create 1-day buckets, but we don't really have multiple days of data just yet. So it will only return one row. But let's run it. So what we can see is that it returned one row, 10th of November, which is today, and 𝗥𝗲𝗃 has a volume of 8. So there have been 8 transactions that involved a 𝗥𝗏𝗃 NFT sale, and these were separate or individual NFTs. So 8 𝗥𝗏𝗃 NFTs were sold in the time period, which is, again, it's not the full day because we are still ingesting data. But let's see if I run this script again. Let's see if the value actually changes. No, it won't. All right. But we have a lot of other queries in the starter kit that you can run. Queries .SQL. There's a lot of interesting queries that you could run on an NFT data set. And using the ingestion script and the schema that is also in the GitHub repo, you can ingest NFT data fairly easily. And using the queries, you can analyze data in different ways. So I think that's all I planned for today. I highly suggest checking out the NFT Starter Kit GitHub repository if you are interested in analyzing NFTs and you are or you want to get started analyzing NFTs. We also have a tutorial as part of this NFT Starter Kit, which walks you through basically everything that I showed you, but it's a more detailed version. So it shows you how we design the schema for NFT transactions, uh, shows you how to ingest time series data, the NFT data, and how to query the dataset using Postgres and Timescale DB. And also, as I said, we provide a Docker image which has pre-built dashboards that use Superset. We also have a Grafana file, Grafana JSON file in the GitHub repository that you can use to import into Grafana to see analysis and visualization in Grafana. So I hope this was useful. If you want to learn more about TimescaleDB, you can check out the docs. We have a lot of useful tutorial in the documentation. I also suggest joining the TimescaleDB community on Slack. We have, I think, more than 7,000 members now. And spread the word on Twitter. We are TimescaleDB on Twitter. You can also tweet me at Attila Toth. And if you're watching the recording, I also suggest following us on Twitch, because we are doing 3 Twitch streams every week: Monday, Tuesday, Wednesday. And if you're interested in TimescaleDB, or if you're interested in data science topics or stocks, crypto data sets, analyzing those types of data sets, you can also ask your questions during those streams. So it's worth following them live. All right. So I think that was all for today, and see everyone next week.